Hi, this is a screencast about naming binary compounds in Chapter 9, Section 2 by me, Hannah. For starters, if you want to write the name of a binary ionic compound, you first should know its formula. Also, the compound must be composed of a monoatomic metallic cation and a monoatomic nonmetallic anion. This part is important. To name any binary ionic compound, place the cation name first, followed by the anion name. Let's try a few examples. Let's say that you have the compound CS2O. What is this made of? The metal cesium and the nonmetal oxygen. This follows the rule I mentioned before. Remember, the compound must be composed of a metallic cation and a nonmetallic anion. So, cesium and oxygen are in group A. This means that they have one charge only and therefore balance one another. Our second example is NaBr, which is similar to our previous example. This would be called sodium bromide. Sounds easy enough, right? But wait, this next part gets a bit trickier. Let's say we wanted to name CuO. If we use the rule above, this would be named copper oxide. However, this is not the complete name. Remember that copper usually forms two cations, copper plus and copper 2 plus, aka copper 1 and copper 2. Now comes the hard part. Which of these forms the compound of CuO? Let's break it down. Looking at the formula, we know that copper and oxygen combine in a 1-to-1 ratio. We also know that oxygen anions always have a 2- charge. So, to balance the charges, we know that the charge of the copper cation must be 2 plus. This means that the compound must be copper 2 oxide. This is important too. If the metallic element, in this case copper, in a binary compound has more than one common ionic charge, a Roman number must be included in the cation name. We need to remember that the charges of monoatomic anions can be determined from the periodic table. This can help us write the names of binary compounds such as SnF2 or SnO2. We will try SnF2 first. Tin's cations usually have a charge of 2 plus or 4 plus. Fluorine's charge is 1 minus. Let's look at SnF2 again. What is the ratio of cations to anions? Yes, correct. It is 1 to 2. So, what must the charge of the tin cation be to balance the 2 minus combined charge of 2 fluoride ions? Yes, it is 2 plus. This would make the name of SnF2 tin 2 fluoride. This one is a bit tricky though because it could also be called stannous fluoride. SnO2 is another weird and crazy binary compound because it is not called tin 2 oxide. Since oxygen is a group 6A element, its anions have charge of 2 minus or a combined charge of 4 minus. Since we know that tin ions can also have a charge of 4 plus, we can conclude that this must be the charge to balance the 2 oxide anions. This would make the name of SnO2 tin 4 oxide, also known as stannic oxide. Before we finish, let's try 2 more examples. First, we will do COI2. COI2 is composed of 1 cobalt cation and 2 iodine anions. Before we start, remember that cobalt forms 2 cations, cobalt 2 plus and cobalt 3 plus. And iodine ions have a charge of 1 minus. However, combined, iodine has a charge of 2 minus. This means that cobalt's ion must be 2 plus to balance the iodide. Therefore, the name of this binary compound is cobalt-2 iodide. Our final example is Li2Se. This contains 2 lithium cations and 1 selenide anion. Lithium's combined and only charge would be 2+, and the selenide anion has a charge of 2-. Therefore, this binary compound is simply named lithium selenide. That's all there is to naming binary compounds. See, it's not that difficult. Thanks for watching. Bye!